Hello everybody, how are you doing? I'm hoping you're doing well. This is the very beginning of chemistry, so I wanted to talk to you guys about why we study chemistry and why it's so fun for me. So we're going to continue on. If you guys would listen in, that would be great. So, for example, spacecraft and going to different parts of the universe is important for chemistry. We can take samples from different places, like they're doing on Mars, and figuring out how things were made and how the solar system was made. So chemists are a big part of when we look at geology of different places on the Earth and all over the universe, and how all the stars and planets are made. So chemistry is a big part of that. So if you like that kind of stuff, that's cool, and chemistry is part of it. So chemistry has to do with everything in the whole entire universe, all the matter, everything that you see, can touch, can smell. Those are all chemicals. So that's why I think it's super fun. It's about everything. It's a science about everything. So that's pretty cool. So matter is what we look at in chemistry, and it's all the things that have mass and that take up space. So that's pretty much everything that we know, except for energy is something different. But matter has mass and it takes up space. So anything that you can see is matter. And chemistry is looking at how those pieces of matter change. And we also look at the energy that happens when those things happen, when those things change. So chemistry is really, really a big, giant science. And you can do a lot of different things with chemistry, so that's why I think it's really cool. Because everything's made out of matter, chemistry affects all aspects of life and most natural events. So it's huge. And there's 5 different areas that we look at in chemistry. And so here's the 5 different things that we look at. We look at organic chemistry, and that's things that have to do with carbon. So our bodies are made of organic chemicals. Inorganic chemicals are all the other things that don't have carbon in them. Biochemistry is using those organic chemicals inside our body and in all life forms, plants and animals, and how those react. And then analytical chemistry can be used in ways of measuring chemicals. So I used to do this a lot as a career. I was an analytical chemist, and I looked at pollution in water and air and soil. And I told the engineers and the people who were in charge of the places that we were looking at, if the area was polluted or not. And then the last one's physical chemistry, and that really has to do with physical properties and with energy as well. So there's 5 big areas of chemistry, and they can overlap. So organic is looking at all chemicals that have carbon in them. So the inhaler that you might use if you have asthma is an organic chemical, and it's having reactions with organic chemicals inside your body. Inorganic is everything that doesn't have carbon in it, and so your bones are made of calcium, so they don't have calcium. The outside bone structure of your bones is inorganic. The inside has organic stuff in it, so it gets complicated. Biochemistry is all the processes that are going on in your body. And when we measure like how much medicine we should add to your body, that's analytical chemistry. So that's really, really important. So if you want to go into medical careers, chemistry is really, really important. And then physical chemistry is how things happen within the body, processes like breathing and your blood flow and things like that, and a lot of the energy that happens in your body. That's physical chemistry. So there's also a division between something called pure chemistry. It's kind of like you think of the mad scientist in the lab doing experiments and trying to figure out how the world is made. That's pure. So it's more like looking at a question just for the fun of looking at the question. And then applied chemistry is more like if you needed to make a medicine for COVID. That would be more applied chemistry. So pure chemistry is just to figure out something, just to solve a puzzle. And there's a lot of chemists and a lot of Nobel Prize winners are really into this, trying to figure out the limits of chemistry and how it all works. And then applied chemistry is something for a practical purpose, especially medications, vaccines like for COVID, all that type of stuff. That's applied chemistry. And pure research, after they solve a problem, just for the sake of solving a problem, then sometimes it can be used for something real that we really need in real life. So, for example, this chemist was just messing around in the lab and figured out this new organic chemical called nylon, and nowadays we use it a lot in our clothing. And after he figured that, after Carruthers figured that out, then he gave it to some other scientists, and they started using it to make clothing. So once a problem is solved, identified, then and they know how things work, then they can use it for something that's useful for us in the world. So, for example, long time, for thousands of years, people have known that they can take willow bark, which is aspirin, chew on it, or then purify it and turn it into aspirin, and that helped people with their pain. And then later on, scientists figured out that actually it's a blocking process in your body, and it blocks the pain receptors in your body, and we can figure out that that helps you with your pain. So they figured it out after they knew that aspirin actually worked. So it can come before or it can come after, depending on the situation. And technology is what we do to find things that are needed in our society that we can fix and make better. So it makes us able to do things more quickly or with less effort or more cheaply. And sometimes we go off the rails and we don't use the technology in the right way, and then there's unintended consequences and things can get messy, like we'll get pollution in the world because we didn't figure out that when we burn something it makes pollution, and then we have to fix that. So technology sometimes can be good, sometimes can be bad. It's a tool. All the tools we use, we can either use them for good or we can use them for bad. So same with chemistry. We can use it for good things and we can mess up and use it for bad things. And so why in the heck do you want to study chemistry, and why did they put you in a chemistry class? This is why. Why are they asking you to take chemistry? All these teachers and counselors and parents and all that kind of stuff. Why in the heck would you want to, why do we have to learn this? So it's really, really helpful to figure out how the world works. And so if you like solving puzzles and figuring out how things are working, that's why chemistry is cool. It can help you get a job. So if you're thinking about medical careers or engineering or a lot of different, you wouldn't think that chemistry has to do with that career. Actually, chemistry comes involved in a lot of careers. And we want you to know how things work so that you can vote the way that you think is best for our coming world. So you guys are the future, and we want everything to turn out well. So we need you to know how things work. So you can figure out how things work. So it's really fun if you like puzzles. Like I said, if you like to solve things, it's really cool that way. And a lot of different careers use it. So people in chemical processes or in lots of things. So especially medical careers. And last, we want you to be able to vote and vote for new propositions that maybe politicians come up with. We want you to vote in an informed way and know the good and the bad about the chemistry that's involved in it. So we want you to have a science background so that when you go out and you guys take over the world, that you'll know what's going on. So we're going to take a little quiz now. Every section we're going to have a quiz. So I'm going to show the question. You think about it. I may have you write the answer. I may not. It just depends on the class day that we're talking about. But it's always good to look at these and think of the answer to see if the things that I talked about kind of go into your mind. So let's try a little quiz. So, which of these areas of study mostly involve compounds with carbon? So is it 1, 2, or 3, or a combination of those things? These are the possible answers up here. So tell me what you think, or think about it in your mind. And by questioning that in your mind, things go into your memory better. So we always want to question and test ourselves and see if we're understanding a topic. And if not, then we need to go back and think about it and relook at it. So the answer for this one is both 1 and 3. Remember, organic is anything with carbon in it, and biochemistry is all those chemicals in plants and animals. So they all contain carbon. All of our body and all of plants' bodies contain carbon. Let's try the next one. So which phrase best describes applied chemistry? So remember, there's pure and then there's applied. So look at these 4 and think of what you think it is. I'll be quiet for a minute. So let's see what you guys decided. Did you come up with D? We're looking for a practical answer. So a lot of people are doing this now, trying to figure out what's causing COVID and how can we eradicate the virus. So this is applied chemistry. We try to figure out quickly how to get rid of this thing. And so why do we want you to be informed? Okay, so we want you to be able to tell us what we should look at in the future. We want you to be running the world in a little while. And so you have to tell us what technology to develop. So that's your, those are your questions. And I'm going to stop recording now and I'll talk to you soon. Thanks. Bye-bye.